Day 14. Thanks for hanging in there with me. Okay, here's our data. Drop you in there. Okay. Submarines polymerization equipment. Produce suitable materials to reinforce submarine nearly. Manual instructions for finding the optimal polymer formula. A polymer template lists a pair of insertion rules. Work out what polymer would result after repeating the pair insertion process. Okay, the first line is the polymer template, NNCB. Following sections define a pair of insertion rules. A rule like AB arrow C means that when elements A and B are immediately adjacent, element C should be inserted between them. These insertions all happen simultaneously. Starting with polymer template NNCB, the first step simultaneously considers all three pairs. First pair NN matches NNC. Second pair NC matches NCB. Third pair CB matches CBH. These three pairs overlap. Second element of one pair is a free. Yep. Okay. All pairs are considered simultaneously. Inserted elements are not considered to be part of a pair until the next step. After the first step of this process, NC, NB, CHB. Sure. After step 5 has length 97. After step 10, 30, 73. After step 10, B occurs 1749, C 298, H 191, and 865. Taking the quantity of the most common element, subtracting the quantity of the least common element, H, produces 1588. Apply 10 steps of pair insertion to the polymer template and find the most and least common elements in the result. What do you get if you take the quantity of the most common elements and subtract the quantity of the least common elements? All right, so the key to this is obviously going to be figuring out what is the best storage strategy here that will allow us to do this. Every insertion essentially doubles the size of the string minus 1, right? So this is 4, this is 7, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So, yeah. So we need something that can grow exponentially, essentially. 3073 is not that big. Does .NET have a linked list? I don't remember. Linked list. Doesn't appear that it does. So list of T has an insert at, right? So list of T, list of int, list of char, q dot insert allows me to, I don't know why IntelliSense is broken. Insert at an index. I have no idea how efficient it is, but that should work. Okay. So, so our first, let's see, so our polymer that starts is going to be data sub 0 to list, right? That'll give us a list of char. That's exactly what we want. And then our insertions will be everything else beyond that. So we're going to do 10 insertions. All right, we're going to do 10 insertions. We need to know 2 characters and then a lookup. All right, so these are going to be lookups. All right, so the instructions are going to be data skip 1. Let's just say parse insertion. Okay, so what we want for parse insertion is we're only going to want to return a dictionary. These are all going to be unique. All right, so dictionary of string to char. This is going to be a dictionary, sorry. What we want here is actually, we can just do this. So our key selector is x substring 0, 2, and our data selector is x sub 2. No, that's not right, because it's 2, 3, 4, 5, 6. It's sub 6, right? Okay. So we'll take a quick look at our polymer and our instructions and make sure everything looks good. Alright, of course we can't see it because we're dumb. Our breakpoint can't see it because we're a little too optimized. Thanks, .NET. Alright, so our polymer NNCB, our instructions are CHB. Okay, so that looks good. We parsed it all correctly. So here we go. We're going to say position is 0. So what we could do is we could... Is inserting really the right answer? Maybe the inserting is really the right answer. Well, we'll try it out and we'll see what happens here. Apply polymer instruction. Let's, what do I want to call this? Let's call this adjust polymer. Do that 10 times, all right? Adjust the polymer. Basically says we don't need that here, we need it here. So position is 0. Original length is going to be polymer length, polymer count. We're going to go one less because we go in pairs. Right. And then we're going to say pair is a new... What are our ways to create a new string? We can do character array. That's exactly what I want. So new string of polymer at position plus polymer at position plus 1. No, that doesn't work, does it? I'd be surprised if that works. Yeah, no, okay. So we just need a new character array for this. Instruction is instructions at pair, right? And then what we want to do is we want to say polymer insert. Insert is index and item. So index is a position plus 1, and then the item is the instruction value. Oh no, the instruction's already the value. It's just the instruction. And then we need to go forward 2. Okay. Let's see. Given this, for each character in the polymer, let's do a console write line of the character, and we want to count. Polymer count of that character. Okay. distinct. I only want this for distinct. And given our instructions, we were told we would see B 1,749 times. We did, and we would see C 298 times. Okay, I'm convinced we're doing the right thing. So then what we want here is counts is a new dictionary of char to int to long. We'll use long for now, right? Counts of C is we just had it right there. Counts of C is polymer count for C. Max is going to be counts max of value, and then we want the key. No, counts max is going to give us the maximum value. Minimum value is counts minimum. And what we want is we want the counts single where k.value is the max, and we want counts.single where k.value is the min. Console right line max, console right line to min. I know that's not the exact thing we want, because it's going to give us the letters. Oh, it's going to give us the keys. Sorry, keys. So that'll give us the letters. 66 and 72. That's amazing. Okay. Apparently a console right line a char and you get an int. Look, I'm just trying to make sure I've got the right values here, okay? Don't make my life so difficult. Counts. Key is a char. Oh my god. That was dumb. Wow, that was dumb. No wonder I printed that. Okay, B and H. Those were the right answers, right? B and H. Okay. So we don't actually want this. We actually want that. And this. Alright, and we want to return max minus min. 1588. That's what we think our number is. Let's go get our real input. That's a lot of stuff, but it doesn't seem that bad. There's our number. Let's go submit. Okay, next part. Resulting polymer isn't strong enough. You'll need to do this a total of 40 steps. Apply 40 steps of pair insertions. What do you get to take the quantity? If you take the quantity of the most, subtract from quantity of the least. Okay, so this is where we're going to find out, you know, what actually happens when we explode this. Are we going to explode? Do we have enough RAM? Okay, I don't know how far we're getting. Not very far. Alright, so clearly the list isn't going to be our friend here. So I guess what we could do is the polymer can just be a string, and we can just start constructing a string, right? So instead of doing this, what we want is a new polymer. We'll start with an empty string. We don't need position. We don't need original length. What we need is here polymer length -1 -2. Alright, so that's our pair. There's our instruction. And we'll say new polymer dot... Oh, you know what? This should be a string builder. New string builder. String builder constructor can take... Alright, what the hell? Why is this thing like... Why can't I get IntelliSense? Restart OmniSharp. String builder is missing. That's great. Hurry up, OmniSharp, restart. There you go. Now I'm getting IntelliSense back. So one of the constructors for string builder should be capacity. Alright, so this is polymer.length times 2. New polymer.append. Polymer and index plus 1. Let's do... Wow, that's not what I wanted. Left, right, left, and right. New polymer, append, polymer sub 0. So we'll start by putting the first character in here, because then what we'll do at the end is we'll do the instruction and then the right-hand side. Right, and then polymer is new polymer dot toString. Let's see how this works. Yeah, that'll finish fast enough, probably. I don't want to have to make a linked list if I can get away with it. Wow, that is really slowing down, isn't it? Alright, while this is running, linked list C#. There's a linked list of D. Two to the 30 is going to be gigabyte, a couple of gigabytes of RAM. Except it's 2 to the 40, so it's not a couple of gigabytes, is it? Out of memory. Yeah. Okay. How do we do this? How do we do this without running out of memory? Exponential growth. Exponential growth. Hmm. I'm going to assume if I try this with the small data, it might work. Just because the data size starts out smaller. How am I going to do this? How am I going to do this? Actually, that's not even going to work either. What if I do it a pair at a time? Alright, what if I focus on CH? Because everything that comes in for CH Alright, even if I did it a pair at a time, let's do this with CH. Is this ever going to finish with just CH? It does. So what if I do this? Yeah. What if I do it? Yeah. Yeah, because then I can do HB, and then I can do BB. Right? Yeah. Alright, so this is my original polymer. If I got back right. Let's do this. Let's say counts is a new dictionary of chart along, right? Now, if what I wanted to do was this, I said for IDX2 is 0, IDX2 is less than polymer.length minus 2. Right? So what if I adjusted a polymer? Subpolymer is new string, no, is polymer.substring of index 2 of 2, right? Then I adjust that polymer. We'll call it 10 times. So we don't need that. You can be index again. Right? I'll say sub counts. Nope, the result is that. And then for each KBP, var KBP in the result. No, and for each C in result, counts sub C. All right. For each var C in polymer, if not counts, key contains key of C, and counts of C is 0. Counts of C++. Alright, so just polymer now needs to return a string. Right. Now we have this. That's fine, you can stay there. So all I need is to make a just polymer. Take a string and a count. And a count. So there's our new polymer. This probably goes back to working with lists, right? Because we did 10 okay with a list. But we'll continue to do it like this. All right, for idx is 0, idx is less than count, double plus idx. Turn polymer. Actually, let's call this P. So your P length, I. And then after you're done, P is new polymer toString, right? All right, let's go back to our original data and run this. We got 2. That's no good. Let's walk through this loop. I've done something wrong in one of the loops. I don't need you. Okay, so our polymer is NNCB, so our subpolymer is NN. The result is N. That's no good. That's our first problem. The new polymer gets P sub 0. Yeah. Left, right, instructions, append the instruction, append the right, and P is the new polymer toString. Why doesn't that look okay? That looks okay, right? Oh, except we don't have to do -2, right? We do -2 is not right. It's -1. So that doesn't seem right either. That should give us... Yeah, so that should give us weird stuff too. I don't trust that either. So the result for this ten times. Oh yeah, let's do this one time. Is NCN. Okay, that's fine. Let's do the just polymer of NCN one time. Really? How could that not be... Fine. NCN, let's do it twice. Let's do it twice. NBCCN. NBCCN. Yeah, so we're growing that correctly. Okay. So that looks okay. So let's grow this 10 times. Okay, so the first time, polymer is an NCB. So the first time we're going to do NN, we're going to get a big giant thing. Okay. Sure, let's do it again. So the next subpolymer will be NC, right? Because our input is NC. Okay, so that all looks good. So 1199, that wasn't right though, was it? No, it was 1588. So what's wrong with our counts? First of all, we never saw H. We should have absolutely been seeing H's here, right? Part of the problem is we can't... Like, we can do this like this. Can we? So let's do 4. Because we have 4 here, right? Let's do 4. Yep. Should have done the result up here. NBBN little tiny notepad from yesterday. NBBN NBC NBB CC NBC N CCN. Now this N is going to be this N. So if index is not equal to 0, then result is result substring of 1. Because we don't want to double count. Is that where we fell through? We double counted? So let's stop here at the counts. How come we never see an H? I'm really confused. Like, we should see NCN, NBC, CHB, right? Alright, let's do this once. Let's set the breakpoints here. Okay, so we've got NCN, NBC. Oh, yeah, we didn't go all the way to the end. That's why we never saw any H's. NCN, NBC, CHB. Okay. Substring can be simplified. Sure, use the range operator, why not? Alright, we want to run 10 of these. Given key H was not present in the dictionary. Oh, yeah. That's true. Let's not do this, right? We'll say if counts contains key of C, then counts of C++, else counts at C is 1. Let's do that, because obviously we see things that aren't there because they're the instructions and not the original polymer. 1588. So if I were to do that again with 40, if I were to do this again except with 40, did I get a giant number? Kind of want to know where I'm stuck. Like, how long is each one taking? Yeah, long ass time. Alright, so that's not the answer. Is there a way for us to count without continuing to explode the size of the polymer? Okay. And just to be sure, how much of this is that? Alright, so it's still all here in adjustment. What about some kind of a recursion instead? Like, we just continue to break the problem down, right? Dictionaries have an add range? They don't, but that's not a problem. What about, yeah. Alright, go ahead, simplify the range operator. So if it's fundamentally a lookup problem, and then a dictionary count merge, all right, what would that look like? Dictionary of char to long. I'll say adjust to. And then we'll say void merge dictionary char long source dictionary char long dest. Let's see, this is what the running total, and then this is a sub count. For each var KDP in sub counts, we're going to say if running has contains key, the subcount key, KVP key, then running KVP key plus equals KVP value. Otherwise, running KVP key equals KVP value. Okay, so that's our merge. So then our adjust is now actually a count. Count polymer elements. And this is an insertion count. Alright. Good about this. So this is going to be a 2-character polymer. Does it have to be? It doesn't have to be, does it? Because we can do the for each here, but yeah, it's okay. We can do this. Yeah, let's do it here. Alright. So your P length, right? Actually, I don't need to pass you because we're just going to use the polymer. Actually, no. We do want P. Because what we want is... Actually, if we know this is always going to be 2 characters... Let me see. So if we bring in 2 characters, what we'll do is we'll convert 2 into 3. Right? What's the right way to do this? So I don't want to double count. So what I'm thinking is if I bring in, like, say, CC, or NN, right? So I bring in NN. I want to convert that into, I bring in NN comma 10, for example, right? I want to convert that into NCN 9, except... So first thing is I want to convert that into NCN. And then I want to recurse. So then I want to recurse NC9 and CN9. But here's the thing, like, I can't count every character. Right? Because here and here, like if I don't count the first character, what if I just count the inserted character? Right? So if I count these, then all I ever want to count is the inserted characters. And then when NCN becomes this, alright, so then I see NC comma 9, right? NC becomes NBC, right? So that becomes NBC, this N, we assume that this C already got counted. We assume this N already got counted because we'll count the first two. We'll count everything that starts. And then we only count the new characters that we add. And then we go around and around. That should work, right? Counts. Let's put counts out here. Okay. Reach var C and counts. If counts contains the key of C, then counts of C++, otherwise counts sub C is 1. Why are you upset? Let's chart along. C is counts. Oh, not in counts. In Polymer. Okay. Yeesh. Okay, so that seeds the database. So that seeds the counts. Right, which means I don't need this merge. Instead, what I need is, given this pair, we're going to call you a pair. Right? So given this pair, I don't need to run a crazy loop on you. Instruction is instructions of the pair. Right? So that gets me the inserted character. Right? If insertion count is greater than 0, I don't know if I stop at 0, if I stop at 1. Let me see, so if I do this 1, so we'll do a double minus insertion count, so it stops at 0. So if you have this, then what I want to do is I want to count Polymer elements with a new string with pair sub 0 and instruction. And then I want to count Polymer elements with a new string with instruction and pair sub 1. And the insertion count has already been lowered, right? All right, so you just return 0, and you can return 0. Except what I want to do right now is I want to count Polymer elements. I want to do, yes, this. Polymer substring index, comma 2. That's our pair. And we'll just do this one time. And we'll see where this lands us. Okay. 124. Clearly have a fucked up curly brace somewhere. Let's go figure out where. This all looks okay. We've got a bunch of people here who think you might be null. Oh yeah, there it is, right there. Okay. So the counts 2221 NCBH. NCBH. Okay, let's do this 2 times now. 2 times now. All right. So our answer is 2461. So N is 2. C is 4. 1, 2, 3, 4. Oh, looking good. B is 6 and H is 1. 1, 2, 3, 4, 5, 6, and 1H. Okay, that looks good. Now, let's do that 10 times. Then let's do this. I don't think I need any of this anymore. Right? I get back 1588. That's good. So on the big data set, I should get this. Which means I should be able to do this again. 30 more times. Oh, that's really slow. Oh, I think because... No, that should be okay. Oh, no, it's not. I have to do it all over again. Console, right line, insertion counts. Actually, I should be able to do this. Problem is, I can't really do it here. Can I? Can't because, like, I have to start over. My counts have to start over. And then this needs to, counts needs to get passed in here. Which can't depend on global counts. Can't tell if I'm being slowed down here by the console or what. Well, definitely something's happening here that's not making me happy. What can I kill? Who's chewing up all my CPU? Yeah, wrong. No, that is actually right. PSAXprep.net. I really don't know which one of these is me. None of these is actually .NET. Did it finally stop? No, it didn't stop. Closing the debug console is going to help me? No. Pkill. I honestly don't know. I think I'm just going to have to kill this Whizzle instance. Whizzle T, Ubuntu 1804. Alright, Advent 2021. Let's open up code. Let's get rid of this console write line. We'll do 10 and 10. Make sure it still runs. Okay. 10 and 20. A little slow. 10 and 30. A lot slow. Apparently the recursion is we're probably killing the stack with the recursion. Probably killing the stack with the recursion. How do we fix that? Not recurse. Man, recurse felt really clean. The first and the last character won't change. Yeah, I know. I don't know how that helps me, though. Do you have a better tip for me? Sorry, that was 20 minutes ago. Shoot. I mean, I could use a stack. So instead of recursing, I could use a stack. The instructions, instead of being based on a string, could be based on double characters. Right. do that. Stack push, pair 0, pair 1. Alright, and then I can say while stack any has, okay, what's not linking here? Count. Count is a property, so I guess we can assume it's not expensive. Let's see. Pair is stack pop. Okay, while we have insertions to do, while we have things on the stack, instructions of the pair, right? And then this. No, not like this. We do it like this. Turn. All right. Otherwise, we're going to do I don't know if this is right or not. No, see this, God, this feels wrong. Yeah, this is, I can't decrement the insertion count here every time. I need to know when to decrement the insertion count. Ah, man. My brain is just not coming up with it tonight. Oh. Roll back. There. Like that. That's never going to need to be there. Go away. String to char. Yeah, I just don't have an answer. Alright, I'm going to stop stream because, I don't know, I got nothing. I got to walk away from the problem for a while. So, anyway, thanks for hanging out. If I come up with a brilliant idea, maybe I'll start the new stream. Maybe I won't. So, we'll see you later. Maybe tonight, maybe tomorrow.